So in the last video we looked at the difference. So I mentioned only one aspect, which is order. I think there are two aspects. One is order and the second one is lag. So when I'm taking the difference, essentially I'll have to specify what is the comparison, what sort of comparison is this, right? Is this comparison related to the previous value or the one before that? So that's captured in the lag. So what we're doing is essentially we're taking this transformation, which is diff log of these earnings, and then what we're doing is we are specifying the lag, which is essentially considering that the current value is at time t, should I compare with t minus 1, t minus 2, and so on. So that's covered by specifying lag as 1, which is comparing the value at time t with the one at time t minus 1. And similarly, you'll have to specify the order. Essentially, this is the recursive or successive nature of taking the difference. So, do I need to take the difference between t and t minus 1? Or do I need to take the difference of difference, and so on? So that's essentially, that's specified on the numerical scale by the order variable. So order 1, 2, 3, and so on. So this essentially computes the difference between the two, difference for a given time series object, and the difference is between two time-spaced values, whether they are adjacent to each other or whether they're separated by time, and that is specified by lag, and the order of differences is specified in order. Now we'll quickly move to complete the Dickey-Fuller test. So I think we did the Dickey-Fuller test. Essentially, this is about understanding whether the values are now looking stationary of the transformation. We'll also look at how these differences look visually, and that is done through a plot just called lag plot. And the lag plot is a mechanism for us to visualize the differences. And for instance, when I specify the values 2, it is looking at t minus 1 and t minus 2. I could add more values, such as let's say 4, to get values for differences between t versus t minus 1, then t minus 2, t minus 3, and t minus 4, and so on. So the line which goes through these points is a smoothing approximation, which we'll cover in